Today's video is about the Pythagorean theorem. This is a theorem we use for right triangles. So in order to be successful with applying the Pythagorean theorem, we need to know what are the parts of a right triangle and why that matters. What even is the Pythagorean theorem, when we can use it, and how do we use it. So getting into the parts of a right triangle. Every right triangle, first of all, has a right angle, and you can tell based on the square at the 90-degree angle. So the legs of a right triangle are the shorter sides of the triangle, and they are directly next to the right angle. Notice how this leg here, right next to the right angle, and this leg here. They are also the shorter sides of the triangle. They will always be shorter in a right triangle. The hypotenuse, this may be a new vocab word for a lot of you, the hypotenuse is the longest side of the triangle, and it is across from the right angle. This is especially important when we get into using the theorem later in this video. Again, hypotenuse, longest side, and you can tell that it's the hypotenuse because it's directly across the triangle from that right angle. So getting into the Pythagorean theorem. In previous videos, I talked about how theorems are statements that need to be proven or supported. I am not going to be taking the time to prove the Pythagorean theorem in this video, but I will be linking several ways that you can prove and support this theorem. So here's how it goes. The Pythagorean theorem says, and this is a mouthful here, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In other words, so I'm looking at the diagram in the bottom right. A and B are the legs of our right triangle. Here's our right angle. And we are going to square them. So A squared, A times A, plus the other leg squared, B times B, is equal to the hypotenuse squared. So C times C. This only works for right triangles. You cannot use the Pythagorean theorem for an acute triangle or an obtuse triangle. It just would not work. And regarding A, B, and C, those are just letters that are commonly used to demonstrate the Pythagorean theorem, but you can choose any letters you want. You could say x squared plus y squared equals z squared. As long as we know that these variables here are the legs, and this is the hypotenuse. Leg squared plus leg squared equals hypotenuse squared. So here's how we're going to use the Pythagorean theorem. We are going to find the hypotenuse in a right triangle. So let me just label the hypotenuse, let's call it x, just for simplicity's sake. I know that the side length x is the hypotenuse because it is right across from the right angle. That side is opposite of the right angle. And the sides labeled 6.5 and 12 are the legs. So again, here's what our theorem says. Leg squared plus leg squared equals hypotenuse squared. So let's replace the values of the legs and the hypotenuse in our equation. So let's do, and the order of the legs doesn't matter. So let's do 6.5 squared plus 12 squared equals x squared, because x is the hypotenuse. That is the longest side of the triangle. Okay, so we need to solve this equation for x. The first thing we need to remember to do is square those lengths. So square all values. What I mean by squaring the values, I mean take 6.5, and we're multiplying it by itself. 6.5 multiplied by itself plus 12 multiplied by itself, and that's still equal to x squared. We can't really touch the x squared yet. We need to square the values we know first. And a calculator is probably going to be handy to you in this lesson. So 6.5 squared, or 6.5 times itself, equals 42.25. 12 squared, or 12 times 12, is 144. And it's still equal to x squared. The next step here. We need to combine like terms. And when I say combine like terms, I mean we are adding 42.25 and 144 together. So that would get you 182.25. I apologize, 186.25. So 186.25 equals x squared. From here, it may have been a while since you've practiced with this, but to solve an equation where x is squared, we need to use the inverse operation of squaring something. So in this case, we are taking the square root of both sides. The inverse operation of squaring something is taking the square root. So next instruction here, find the square root of both sides. So remember that we use the radical symbol, looks like this, to take the square root or find the square root. So we're taking the square root of x squared, which is going to cancel out and give us x. And now we're going to take the square root of 186.25. So x is going to equal the square root of 186.25. Again, this is where a calculator is going to come in handy. We're actually going to estimate this value. We're going to round to the nearest tenth. So if I find the square root of 186.25, I'm going to get approximately 13.6. So x is about 13.6, which works out really well because we got a result that tells us 13.6, the hypotenuse, is the longest side of our triangle. Moving on to finding a leg in a right triangle. In this situation, we're going to have to set up the Pythagorean theorem a little differently. So what we're given is a leg that is 10.5 units, and I know that this side length of 12.7 is not a leg. This is the hypotenuse because it is right across from the right angle. It's not next to the right angle, it's across the triangle from it. So this is my hypotenuse. So that's how we know we are missing a leg. Let's call it M. And this is to demonstrate we get to use whatever variables we need to solve the problem. So you can use x, m, l, s, whatever works for you. So when we set this up again, the Pythagorean theorem says leg squared plus the other leg squared is equal to the hypotenuse squared. So we're going to fill in the information that we know. We know that we are missing side m. So we're going to say m squared plus the other leg squared, so 10.5 squared, is equal to the hypotenuse squared. So that's 12.7 squared. So we need to square everything once again. So m squared plus, and then we're going to multiply 10.5 by itself. 10.5 times 10.5 equals 110, not 100, 110.25, and that's equal to 12.7 squared, or 12.7 times 12.7. And so that equals 161.29. So here's where solving the equation is going to be a little different. We need to get m by itself. Right now we have the term 110.25 in our way. So right now I see that we are adding 110.25 on the left side of the equal sign. We're going to do the opposite. The inverse of addition is subtraction. We're going to subtract 110.25 from itself and from the terms on the right side of the equation. So this cancels out, and we get m squared equals, let's see, the difference between 161.29 and 110.25 equals 51.04. So from here, just like the previous problem, to the inverse operation of squaring something is taking the square root. So m equals the square root of 51.04. When you take the square root of something, you're asking what number times itself is equal to the number inside the radical. So in this case, what number times itself equals 51.04? In the past, we've learned to estimate that number without a calculator, but for the sake of ease today, we are going to use a calculator. So m is approximately, and then let me type in the square root of 51.04, and that's equal to the nearest tenth, about 7.1. Okay. To check your answer, you could plug in the value of m into your equation. Let me demo that right now. So my equation at the very beginning looked like this. M squared plus 10.5 squared equals 12.7 squared. Your result is not going to be exact if you're estimating the variable here, but it should be close if you solve correctly. So value of m is 7.1. I'm going to plug that in. So 7.1 squared plus 10.5 squared equals 12.7 squared. 7.1 squared, 7.1 squared equals 50.41. So you can already tell that it's not going to be exact, but it's going to be close. So we've got 50.41 plus 110.25, and I'm going to write the sign approximately because we know our answer is not going to be exact. It's okay if it's within a few tenths. And then 12.7 squared was 161.29. So let's add on the left side of the equation 50.41 plus 110.25, and we get 160.66 on the left side. It's pretty close. It's pretty close to 161.29. So I would count this as a win here. We solved this equation correctly. We just had to estimate a little bit. If you round to the nearest hundredth instead of the nearest tenth, you're going to get a more accurate answer. All right, I've got a couple example problems here. The first one is talking about TV dimensions. And if you didn't know already, your TV, when you purchase it, is measured based on how long it is diagonally instead of the dimensions of its length and width. So your standard 52-inch TV, the 52 inches is the length of the screen from corner to corner diagonally. So let me draw that here. So here's your screen, and the length diagonally from corner to corner is 52 inches. So our problem is asking, if you purchase a 52-inch TV that is 45.3 inches wide, how tall will the screen be? So this is an example we can use the Pythagorean Theorem in, because we're dealing with a rectangle here. TVs are not they're not circular, they're not oval, they are rectangles. So we know that the angles on this TV are all right angles. So we're dealing with right triangles here. So the hypotenuse of this triangle, the longest side, is that 52-inch measurement. The width of the TV, the problem says, is 45.3 inches wide. So we need to find the height. Let's call this h. H for height. So we can use the Pythagorean theorem to solve this problem. So looking at just this triangle here. Here's my right triangle. I'm going to set up the theorem. So leg squared, so h squared, because h is one of my legs, plus 45.3 squared, the width is a leg as well, is equal to the hypotenuse squared. And the hypotenuse in this case is 52, and we are going to square that as well. So h squared plus 45.3 squared equals 52 squared. We are going to, like before, square both of the sides. So 45.3 times itself is equal to 2052.09, and it's equal to 52 squared. So 52 times itself is 2,704. Like before, we're trying to get h by itself. The inverse of adding 2052.09 is subtracting that number from both sides of the equal sign. This cancels out. So h squared equals, so 2,704 minus 2052.09. And you get 651.91. Just like before, the inverse of squaring a number is taking the square root of it. So we are taking the square root of h squared and the square root of 651.91. So h is going to be, and we're going to have to estimate again, we need to find the square root of 651.91. And let's round to the nearest hundredth this time. So 8, actually let's round to the nearest tenth. It's going to be approximately 25.5 inches. That is going to be the height of the TV. So not only is this it's aligning to real life a little bit. Usually with modern day TVs, the height of the TV is much less than the width. And we know that the 52-inch dimension, the hypotenuse here, is still our longest side. So I'm confident that we solved that correctly. Another problem, we're talking about walking certain routes in a park. When Sydney got to the park, she decided to walk around the gravel pathway to get to the baseball field. She walked 600 meters east, then 800 meters north. How many meters less would she have to walk if she cut diagonally across the park? So there's a lot to unpack here, and this is a problem we're going to have to visualize again. So let's say we know that Sydney walked 600 meters east and 800 meters north. So let's say Sydney is here. And we know that Sydney is going to walk to the east or right from her location, if we're looking at like a sandbox view from the top down. So this is 600 meters east. And then from there, she says she walked 800 meters north. So a little bit longer than before. 800 meters. And this is where the baseball field is. I'll call that point B. This is the baseball field. So it's asking how many meters less would she have to walk if she just cut diagonally across the park. So going from her current location all the way up to point B. Point B here. I'm going to estimate here. This is our unknown value. We don't know what this side length is. So just to clarify here, if we're walking true east for 600 meters, and then we're walking true north 800 meters, that means we're essentially, and this may not be completely exact, we are walking and turning at a 90-degree angle. So x, in this case, is going to be the hypotenuse of the triangle we just formed because it is directly across from the right angle. So now we need to build an equation to solve this problem. So again, we know that the 600 meters and 800 meters are legs. X is the hypotenuse. So this is going to affect how we set up our Pythagorean theorem. So one leg, 600, is squared, plus the other leg, 800 squared, is equal to the hypotenuse squared, so x squared. From here, we square our sides. 600 times itself is 360,000. Plus 800 squared. 800 times itself, which is going to be 640,000, is equal to x squared. So we combine like terms. We add 360,000 to 640,000, and we get 1 million. 1 million equals x squared. The inverse operation of squaring x is taking the square root. So we're going to take the square root of both sides. So x is going to equal the square root of 1 million. So the square root of 1 with 6 zeros behind it is 1,000. And we know that we are measuring in meters. This is 1,000 meters. So the distance between Sydney and the baseball park, if she just walked diagonally across the park, would be 1,000 meters. But that's not the end of our question. It's asking how many meters less would she have to walk if she cut diagonally across. So let's look back to her original path. If she walked 600 meters east and then walked 800 meters north, we know that the original path, if you add those together, is 1,400 meters. But if she were to cut diagonally using the problem we just solved, then her path is only 1,000 meters. So really, if she were to just go from point A to point B, she would be walking 400 meters less. And I'm sure you can all work this out logically. The shortest distance between 2 points is a straight line. Okay, so that was the end of our lesson. Your assignment is going to be lesson 12.1. This is going to be due Thursday if you have me for a third period, and Friday if you have me for 4th through 6th period. Make sure that you are checking the assignment instructions for how to submit your assignment correctly. If you have public questions, make sure you show up to office hours. And if you have private questions or would like to work with me more privately, just send me an email. We, after Monday and Tuesday's class, are moving into the converse of the Pythagorean theorem. So stay tuned for that. Let me know if you have any questions. Take care.